Oh, hello, students. This session is with regard to similarity. Like some of you had doubts regarding similarity. Well, I'll just let's just walk through the syllabus with regard to similarity. What does it say? If you look here, okay. So similarity. Just I'm sharing this syllabus copy with you. See, it says similarity conditions of similar triangles, comparison with congruency, and the keyword being proportionality. These things are going to have SSA, SS, and AA. Applications of basic proportionality theorem. Okay, so again, it's clearly mentioned that there are no proofs. So you will not be asked proofs. You'll be making use of theorems though. So coming to what exactly is this similarity all about? Now, in grade 9, you would have talked about congruency. You know what is congruency, right? If I'm just going to tell you in a layman's language. So when you have two triangles which are congruent, yeah, let's say A, B, C, and D, E, F, you know very well what is congruency. In congruency, when we say the two triangles are congruent, it means one is an exact copy of the other. So congruency is referring to shape and size, as in the shape is the same and the size is the same. This is in a common man's language. So mathematically put it, you would say all the sides are equal and all the angles are equal. So equality, that is, all the sides are equal. Let me just rephrase. All the corresponding angles are equal. All the sides are equal. So equality of sides and equality of angles. So here I could say angle A is equal to angle D, angle B is equal to angle E, isn't it? And angle C is equal to angle F. So that's how I can use the symbolic correspondence. ABC is congruent to triangle DF. So triangle ABC is, so A coincides with vertex D, B coincides with vertex E, and C coincides with vertex F. And the other things also fall in place. That is AB is equal to DE, isn't it? Likewise, you can say BC is equal to EF. And we can also say AC is equal to DF. All right, so this is all about congruency, which you already know. It's like familiar to all of you, right? So AB is equal to, and AC is equal to DF, and what else? BC is equal to EF. So this symbolic correspondence going to speak a lot. And of course, because the vertices are coinciding, angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. That means one triangle is just an exact replica and another copy, a copy of the other in terms of shape and size. So coming to similarity, so we have seen conditions for congruency in grade 9. If you just want to go back, see, I'm trying to take you back to congruency so that you can appreciate similarity better. SSS, isn't it? If all three sides of one triangle are equal to all three of the sides of the other triangle, the two triangles are congruent by SSS. Likewise, we have seen SAS, two sides of the included angle. Then we had ASA, that is two angles and the included side. And then what we had, the two angles and the other side. Yeah. AS is just a variant of ASA. So, and then you also had RHS. RHS, of course, is applicable only to right angle triangles. If the hypotenuse and one side of one right angle triangle are equal to the hypotenuse and the other side of the other right angle triangle. We have seen all this. So which means you're not going to sit and measure all the angles and all the sides. So you're just going to use any of these criterion, and if it satisfies, that means we could say that we could confidently say the two triangles are congruent, isn't it? So the same thing with similarity. So now the buzzword is not equality. In congruency, what is it? We said equality. Equality of what? Sides and angles, isn't it? But in similarity, the buzzword is proportionality. Proportionality of what? Now, So when I say two triangles are similar, it means they have the same shape. Okay, but not necessarily the same size. So size can vary. Yeah. So in other words, one is a blown up version of the other, or one is a zoomed out or zoomed in version of the other, I could say. See, let's say I have a triangle cat and then the other triangle dog, let's say. So the in terms of shape, they would look the same, but in terms of size, they are different, isn't it? So that angles will be equal. See, the shape is given by the angles, right? Because the angles are equal. Angle C is equal to angle D. Angle A is equal to angle O. And see here, angle T is equal to um, is equal to angle G. You can see that, isn't it? So the two triangles are similar, I would use the word. But the angles are equal. Equality refers to angles and proportionality is for sides. Equality of angles and the sides are proportional. That is, I could say the two triangles are similar. Triangle A, or okay, I'll just name it as CAT. CAT is similar. See, note that for congruency, I used this symbol, isn't it? See here. For congruency, I was using this symbol, right? So for similarity, it is without the equal to. So just this operator. So triangle dog. Okay. So the two triangles are similar. Now again, what do I mean by similar? Vertex C coincides with vertex D. Vertex A coincides with vertex O. And of course, vertex T coincides with vertex G. And correspondingly, that is the angles are equal. Equality of angles. That is, angle C is equal to angle D. Angle A is equal to angle O. And angle T is equal to angle G. And the sides are proportional. What do I mean by sides are proportional? Go with the order. CA by DO. We don't say CA is equal to DO. That is incongruency, right? Here CA by DO is equal to, which is the other pair, AT by OG. Okay. And also equal to CT by DG. CT by DG. Got it? So this is proportionality of sides. So remember, in congruency, the corresponding angles are equal and the corresponding sides are proportional. But in similarity, the angles are equal, but the corresponding sides are proportional. So it's all about proportionality. And then one will be the blown up version of the other. The shape is the same because the corresponding angles are same. So again, every time, just like in the case of congruency, I'm not going to sit and measure all the sides and all the angles and then say, yes, this triangle is similar to this triangle. No, it's not going to work out that way. See, I'll just take one triangle. Some name I'm going to give it like, okay. Okay, so I'm just, I'm going to have two triangles. I'll just draw one little blown up compared to the other, let's say. So now I'm going to have two triangles which are similar. When I say similar, see, I'm just drawing it to scale. It's a rough sketch, but trying to make it kind of look similar in shape. Let's see. Yeah, so you see, so the two triangles will be similar. This is the symbol that I'm going to use for similarity. Here again, when I say triangle cow is similar to triangle hat, it means that, of course, the angle C will coincide with angle H, equal to angle H, and vertex O is with A, so angle O will be equal to angle A. Angles are equal, right? The sides are proportional. And angle W will be equal to angle T. So that's it. What else? About the sides, we say they are proportional, right? That means if CO is, let's say, 3 centimeters and HA is, let's say, 6, CO by AH or HA is equal to OW by AT. So if OW is 4, naturally AT has to be 8. Okay. Because 3 by 6 is equal to 1 by 2, 4 by 8 is equal to 1. They're proportional. Sides are not equal. 3 is not equal to 6. 4 is not equal to 8. But 3 upon 6 is equal to 4 upon 8. So you can see that the sides are proportional. Okay. And CW will be equal to, not equal to, you can say CW by HT will also be equal to 1/2. Whatever is CW and whatever is HT, the ratio will be 1/2 if they are supposed to be similar. So if I give you two triangles and I just mention this point of information, this piece of information, that is, I'm just going to say that three sides, I'm putting the strokes, but it doesn't signify equality, it just signifies proportionality. Remember this. So if three sides of one triangle are proportional to three sides of the other triangle, then the two triangles are similar by SSS. So I don't have to go and measure the angles. It is understood the corresponding angles will be equal. So let us say I have two triangles. Okay. So triangle cow and triangle hat, whatever. I'll take the same values that I took earlier. See, CO by AH. I'm putting the strokes. It doesn't symbolize equality, remember. It's just for me to understand and for you to understand. So suppose CO is 3, let's say 4 and 5. So if they are supposed to be similar, then CO is going with AH, right? If it's a 6, then this will also be 8 and this will be 10. It's a blown up version of this, right? In other words. So CO by AH is equal to OW by AT is equal to CW by HT. The three sides are proportional. SSS similarity criterion, right? So in congruency, the sides are equal. Here it is not equal, it is proportional. Then we can say the two triangles are similar by SSS. And what else? The corresponding angles are equal. Angles, when it comes to angles, it's equality. So between the corresponding sides, that is CO and OW, let us say it's angle O. What is the corresponding angle in the other triangle, the other pair? That is angle A, isn't it? You can see that. So 3 goes with 6 here. 3 will go with 6, right? And you can see that OW, it goes with 80, isn't it? And the other one is, I'm just putting in different colors, you can see. CW goes with HT, right? OW goes with 80, CW goes with HT. I'm just put different colors. So between yellow and blue, you have this angle O here, right? And that will be equal to angle A in the other triangle. Likewise, between yellow and green, that is OC and CW of one triangle, there you have AH and HT. Just follow this. You have angle C, right? That will be equal to angle H. You can see here. Similarly, between green and blue, you have this triangle. That is this angle, that is W, between CW and OW. In the other triangle, it is between HT and AT. That is angle T. They are similar. So the angles are equal. So the corresponding sides are proportional. The corresponding angles are equal. It is implied. I'm not going to still measure the angles. Just with the knowledge that the sides are proportional, I can say that the two triangles are similar. Okay. So that is it. Next is I'm giving you two triangles, and I'm not giving you three sides. I'm just saying that, wait, I'll just draw two triangles. I'll just take two triangles, cow and ant. Just taking different vertices. See, so let's say that CO, I'll give you the proportionality, that is CO by AN is equal to OW by NT. Now I don't give you the information or anything with respect to the third corresponding sides of both the triangles. I just give you two sides, right? S and S, two sides. But the included angle, that is supposed to be equal. Let's say angle O is equal to angle N. Yeah. So what have I done is I have told you that CO is proportional to A. CO by A is equal to CO by AN is equal to OW by is equal to OW by NT. You can see that here, right? I've just put those colors here. So that is CO by AN is equal to OW by NT. You can see that here. So two sides are proportional here of one triangle are equal to the two sides. That is proportionality with respect to two sides. I have not mentioned anything about CW of the first triangle and AT of the second triangle. But I did mention something else here. What am I telling you? That this angle O, that is the included side, is equal to angle N, which is the other included angle in the other triangle. So angle O is included angle here, angle N is the other included angle here. So SAS criterion for similarity. That is, if two sides of one triangle are proportional to the two sides of the other triangle, and the included angles are equal, which included angle, that is the angle included between these two corresponding sides, whichever I've mentioned, I've taken for proportionality, right? Those two. So angle N is equal to angle O. Then I can say the two triangles are similar by SAS, side, and the included angle, SAS criterion. So SAS criterion is a way to establish similarity. And other things will fall in place. Naturally, the other third side will be proportional and the other angles will be equal. That is, angle C will be equal to angle A in this case, and angle W will be equal to angle T, as you can see. So I just mentioned two sides which are proportional and the included angle between them are equal. So always remember, angles, it's about equality, sides is about proportionality. The next thing is, I don't have anything else. I don't have RHS here, like unlike congruency, but we have something called AA or AAA. Now, why AA? Or they both mean the same. So let's say I have a triangle. I'll just take a triangle like this. Okay. So COW and I'll take another triangle HUT. So now I'm not going to talk about sides here. What I will say is the two triangles are similar just based on angles. So I will tell you that angle C is equal to angle H, okay, and angle O is equal to angle U. See, angles, it's about equality, I told you. When you talk about angles in respect to similarity, with respect to similarity, it has to be equality of angles, proportionality of sides. Angle C is equal to angle H, angle O is equal to angle U. See, angle sum property. By angle sum property, we know that if two angles, all the three angles are up to 180. If two angles are given, you can easily find a third angle, isn't it? That is, for example, in this case, I gave you only two angles, angle C and angle O from the first triangle. And on the other triangle, we have angle H and angle U. That is enough to establish that the two triangles are similar. That is A criterion. If two angles of one triangle are equal to two angles of the other triangle, the two triangles are similar by A criterion, A similarity criterion. The third angle will be equal because of angle sum property. That's what we are trying to see here. That is, angle W will be equal to angle T. I mean, I don't have to go and find that out, but if the if the angles were given prior, that is, angle W was given as equal to angle T. I mean, if angle W and angle T are anyway given, then it would be A triple A. They both are the same. It's like I don't have to find a third angle. With just the knowledge of two angles, I can say that the two triangles are similar. Like example, if angle C is 60 and angle O is 40, angle W will be 80. Likewise, angle H is 60 and angle U is 40, right? 60 plus 40, 100. Angle T has to be another 80. Why? Whatever be the triangle, nature of the triangle, big, small, whatever, acute angle, obtuse angle, equilateral, right angle, doesn't matter. They have to add up to 180 degrees. And that's why. So if you have all the three angles with you, you can say triple A criterion, or if with just two angles, you can say double A criterion for similarity. So if two angles of one triangle are equal to two angles of the other triangle, the two triangles are similar by A criterion, and that is enough. And the other things will fall in place. That is, corresponding sides will be proportional. Got it? Now, angle AT is opposite to CO in this triangle, side CO, and then angle AT is opposite to side HU in the other triangle, isn't it? So CO by HU will be equal to, look at 60 now. So in the first triangle, 60 degrees is opposite to side OW. In the second triangle, 60 degrees is opposite to UT, right? So it will be OW by UT. And the third triangle, you have CW as opposite to 40 degrees. And in this other triangle, it is third angle, that is HD is opposite to 40 degrees. So we can say that CW will go with HD. So we can establish proportionality of sides also here. So this is it. So we have seen, what have we seen so far? Triple S criterion, two sides and the included angle, and two angles are given, or if three angles are given also, it's fine. They are identical criterion, I could say. By knowing two angles, you can also get the third angle, right? So these two. So in the first two cases, the first case, three sides are given. In the last case, angles are given. In between case, SAS, you have two sides which are proportional, and the included angle in between will be equal. Okay. So this is all about similarity so far. So you will have very basic problems that are being asked. I'll just take you to the specimen paper here. See, if you look here, let me zoom this out. Wait, yeah. In the given diagram, the triangle is similar to DEF by the axiom, criterion or axiom. I use the word criterion. It means it can also stand for axiom here. So this is from your specimen paper for 2023. See here, it is very tempting to use RHS because like under the pressure when you're writing MCQs, solving MCQs, you are writing an exam, time bound exam. You want to save on time. MCQs, right? The options are there. They seem to be easy, but sometimes MCQs can be a bit confusing because you'll start thinking, you'll start doubting your own answers. It has happened. So it's not RHS because you don't have anything of RHS for with regard to similarity, isn't it here? You have two right angle triangles, no doubt. But there's nothing about hypothesis given. So that also tells you can't use RHS, and it's not congruency, by the way, it's similarity. There's no RHS ruled out. Then three angles, only one angle is given. So even that is ruled out. And then three sides are also not given, right? Only two sides are given. So this is how it is. So two sides and the included angle of this triangle are equal to the two sides and the included angle of the other triangle. And the two triangles are similar by which criterion? They are similar by SAS criterion. Now, if I want to establish the symbolic correspondence, the question doesn't say so, but let me just go one step ahead. See here, triangle ABC, yeah, is similar to what? Obviously, see, first we can go with the angles. Angle B is at 90 degrees and angle E is at 90 degrees. So E is going to come in the center here. Next what? So B will be mapped to E, obviously. Next we have to see, that's why I said look at the proportionality of sides. The sides should be proportional, isn't it? Now, if you look carefully, we can say 4 upon 24 is 1 by 6. Yeah, 1 by 6. 4, 6 or 24. And 3 upon 18 is 1 by 6. Now, how does this look? How does this appear to me actually? So if you're going to like flip it over, okay, if you're going to rotate, it's like D would come and go and sit with A, right? If you flip it over, and E will sit with B and F will sit with C. You can see here. So F will come here and with A, D will come. It's like you rotate this, okay? So if you're going to align it, if you're going to align it, see, I'm going to flip it over, and then it will be like this. This is E, right? This is F. This is 90 degrees. EF is 18. See, it's going to sit with 3, 6 are 18. And this is, of course, B. And this is 24. So you have to imagine a little here. So the flipped over version of this is this. And if you look at it, the big picture, you're going to get all this here. So 3 by 18 is 1 by 6. 4 by 24 is 1 by 6. Sides are proportional. The included angle is SAS. So here, this MCQ did not ask you to find out all this, or neither did it ask you to go and establish symbolic correspondence or something. Nothing of that sort here. But then you can realize that this is how it is. Okay. That AB is going to go with DE, not with EF. So this is one example here. Then coming to BPT. The BPT is, I'll just take it to the syllabus. See. So we have seen this comparison, right? Where is congruency? Congruency is equality, equality, sides equality, angles equality. Here, corresponding angles, I mean, and corresponding sides. In similarity, it is corresponding angles are equal and the corresponding sides are proportional. Then we have seen the criterion, right? The 3 conditions, and proof, of course, is not there. And then BPT application. So now suppose I have a triangle ABC. In grade 9, you have learned MPT, midpoint theorem, right? Now, a more generalized version of this is your BPT. So I have a triangle ABC, and I'm going to consider that triangle has 2 sides, right? So I'm going to draw a line cutting the 2 sides. Let's say side 1 is AB, side 2 is AC, side 3 is BC, let's say. Now what I'm going to do, I'm going to draw a line which is cutting both the sides, and it is parallel to the third side. Can you see? See what I've done? So I'll call it as some DE. The line is, of course, it's a line segment. The line is cutting the sides at D and D respectively. The line, of course, will extend, right? Line has no definite length. So you see, what do I get here? DE is parallel to BC. Yes, DE is parallel to BC. So I have just drawn a line which is cutting the 2 sides in such a manner that that line is parallel to the third side. It is cutting the 2 sides, the first 2 sides, and it is parallel to the third side. That's it. And it's not that, see, in MPT, what is it? D is the midpoint of AB, E will be the midpoint of AC. That is where in MPT. Now, this is not MPT, this is BPT. So here, D can be anywhere here, and E can be anywhere here. It's just that that line is parallel to BC. Then in BPT, what we say, AD by DB is equal to AE by EC. So AD by DB is equal to AE by EC. This is the essence of BPT, the basic proportionality theorem. This is also known in, of course, not in your book, not in Selena, but in certain sources, if you see, it's also called as the Thales theorem. So a consequence of this is this: if D is parallel to BC, so I'll put an if clause there. If D is parallel to BC, then I can infer that AD by DB is equal to AE by EC. Okay. So we don't have to prove it. You can actually prove it using the properties of the corresponding angles, and in a the 2 sides are behaving like transversals for parallel lines. You have to go back to Euclid's geometry. That's not required. So this is one thing. AD by DB is equal to AE by EC. Or you can even say, I'll just draw the image again here because I'll be using these results. So these results you can make use of. So I'm just drawing that diagram again, ABC. I'm going to cut this, and this DE will be parallel to BC, isn't it? So what? If DE is parallel to BC, one result is AD by DB is equal to AE by EC, and the corollary, that is the extensions of the theorem you can use, that is dB by big side. dB is a part, right? dB by AB will be equal to EC by big side is AC. You can see that AC is the big side, AB is the big side, dB is the lower chunk, and the other side EC is the lower chunk. Likewise, you can also say AD by AB, that is smaller, the upper chunk by the big side, is equal to AE by AC. This also, so these three results, AE by AC. AC is the, so this is it, yeah. AD by AB is equal to AE by AC. Or I can even say DB by AB is equal to EC by AC. BPT is the first one, that is AD by DB, upper chunk by lower chunk is equal to upper chunk by lower chunk, AE by EC. These are all the applications of BPT. Okay, like see what is happening here is you have this mother triangle ABC. Yeah, and you're getting another triangle here. This is D and this is E. So it's like you have the mother triangle, the big triangle ABC, and the baby triangle. I'm just going to redraw that here, ADE, isn't it? And angle A is common to both the mother and the baby triangle. And here, angle D will be equal to angle B because they are parallel lines, isn't it? So angle D will be equal to angle B, and corresponding angles. Angle E will be equal to angle C, again corresponding angles. So that is by AA criterion. The mother triangle is similar to the daughter triangle. That's, and down you get a trapezium. Now previously like if you go back to the previous years, it's not required, just saying that, just informing you that they had problems where you had to find the area. Now we don't have that sides, the area being equal to square of the sides proportional. No, that's not there in the syllabus this year. So you can leave out that part. But this is all about BPT. So we should know the criteria for similarity. And remember, angles are equal, sides are proportional. Just keep a note of that. SSS, SAS, and you have AAA or AA. So I hope so far the explanation has helped you. So continue studying for your exam. You have a few more days left, maybe just a week, I could say. So all the best.